term factor A, what is it exactly? Do you think it would be temperature dependent? What do you think? How many people think yes, it would be temperature dependent? How many people think no? Some people are not going to commit. The answer is no. So let's think about what factor A is. So factor A is the rate constant at some really, really large temperature. So if we look at this plot, the natural log of K equals the natural log of A, or K equals A if you're along this axis here. If you're along that axis here, that's at 0. So that's when 1 over temperature equals 0, then the rate constant equals factor A. What would be true about the temperature for 1 over temperature to equal 0? Very big. So at the biggest, hugest temperature you can imagine, the rate constant is going to equal factor A. And so factor A depends on the nature of the material being studied, and you would have to determine what that value is. But it's definitely not temperature dependent. It's the value of the rate constant at an enormous temperature. So what about activation energy? Do you think that's temperature dependent? Why don't you tell me what you think? All right, let's just take 10 more seconds. All right, so I'd like you to discuss this amongst yourself and see whether you're happy with this answer. Vote again? All right, go ahead and vote again. All right, 10 more seconds. And the correct answer is? So the good thing is I think most of you will remember this answer. So the activation energy is not temperature dependent. You can calculate what the activation energy is by plotting the rate constants versus 1 over temperature, and then you get it from the slope of the line. So activation energy depends on the nature of the material, but it isn't temperature dependent.